If you're watching this video, you should have already watched the video about the notes and seen what a scatter plot was. Really, for this video, you should just be checking your practice. Please try these on your own before you listen to the explanation. Okay, so our first scatter plot has oil changes versus engine repair. So at the bottom here, we're going to see the number of oil changes per year, and then the side tells us how much money they're going to spend fixing their engine. First, they want to know what kind of relationship is there between the two variables. Well, if we look at the line that they've drawn, it kind of shows us what happens. As we move from left to right, just like we read a book, this line is going down. So the kind of relationship we have here is a negative one. Remember, if it goes from left to right and goes down, it's negative. It's going left to right and goes up, it's positive. How many oil changes would you expect someone to have if they spend $300 on repairs? So we're going to have to use our line of best fit to help us predict this. So we have $300 worth of repairs would be on the y-axis. So if we look at $300 and kind of go across, we're going to end up at around 5 number of oil changes per year. So our answer was C, 5. For someone who spends $600 on engine repairs, how many oil changes would you expect them to have? Well, if we look at $600 and we come across to our line of best fit and we look down, we would only be at about 1 oil change per year. There is a data point on here that has 0 and it goes to 600, but we wouldn't pick 0 because we are talking about what we expect, not actually what the data shows. So to use for what we expect, we're going to look at our line of best fit, not the individual data points. For our next example, we have restaurant sandwiches, and they're going to tell us the comparison between the calories in the sandwich and the fat that's in the sandwich. So first, looking at our scatter plot, I drew in my line of best fit just to help me answer my questions. Okay, so remember when you're drawing these line of best fit, you want to make sure that you're kind of getting into the middle of the group of points. And there can be some above and some below, but you kind of want to draw the line through the general trend of our points. So if we look at our line and the scattering of our points, they're both moving up in an order from left to right. So then our correlation is going to be a positive one. There is a correlation. And sometimes there's not, but here they're all moving in the same direction. The more fat you have, the more calories you have. So it's going up, it's positive. How many calories are in a sandwich that contains 17 grams of fat? This is not asking us what we'd expect to happen, it's asking what is actually true. So we need to look for that specific data point on our graph. So if we're looking for the sandwich that contains 17 grams of fat, we're going to come down to our x-axis, because that's where our fat grams are. Between 15 and 20, we're going to find our 17. So if we look, there's our point right there, and it goes across to 400. So it would be about 400 calories. How many grams of fat are in our sandwich with 600 calories? Again, it's not asking us to predict or what we'd expect, so we're going to use the actual data points on our scatter plot. So we have to find the sandwich that has 600 calories. So now we're going to look at our y-axis. There's 600 calories. We're going to go across. Here's our data point right here, and if we scroll down, look, it's at 30 grams of fat. Our next one says predict how many calories would be in a sandwich with 10 grams of fat. So we're not actually using any of the points. We're going to use our line of best fit to help us. And so from our line of best fit that I drew, we're going to look at 10 grams of fat and kind of go to our line. Well, we would predict it to have around 350 grams of fat. How many grams of fat would you expect in a sandwich that has 900 calories? Again, the word expect is our key word here, right? They want us to try to predict based on our line of best fit. So predict and expect are our two keywords. Well, 900 calories is going to be off our graph. We only go up to 800, and then the next one, since we're going up by 50s, would be 850. So then 900 would be somewhere up here, right? But we can see that this trend is going to keep going up, up, up. And so we're already at 45 as our last one in grams of fat. So we know it's going to have to be bigger than 45. So if we look, we're going to say it's about 50. Because 40 would be too low. It's going to be about 700 calories. And 45, again, would be a little bit too low. It's going to be about 750 to 800. So then we want to get up to 50. So just a general review of our different types of scatter plots. There can be 4 correlations. Positive goes up from left to right. Negative goes down. So we've seen one of each of those. The first one was negative. Okay, our second one was positive, but then some of them could have no correlation, so they're not really going up or down in one direction, or they could be a constant, which means they stay level, they go straight across. So just to check our answers for this one, the first one is going to have no correlation. These are all scattered. They're not going up and they're not going down. They're just kind of all over the place. Our next one's going to be negative. They're going down from left to right. Then we have positive. This one's going to be none because it doesn't do either of those positive or negative things. They're all kind of just clumped together. The circle of these is just none again. And then our last one is going to be constant. Constant is the one that's like kind of flat. It just goes straight across. One of your variables is very consistent. It doesn't change. Okay, the backside. Here we have a scatter plot that shows age and pets owned. So what kind of correlation is there? Well, again, this one, there's no positive or negative. It's just kind of all over the place. There's no correlation. So then our second follow-up question says, can we predict how many pets an 80-year-old person might have? Well, no, we can't. We can't draw a line of best fit here. It wouldn't match any of our data. It doesn't follow a trend. And so if we can't draw a line of best fit, we can't make any predictions. It's all kind of just random. Our next one is television size and price. So the trend here is positive, right? It's going up. The bigger the television is, the more it's going to cost. So then I drew my line of best fit here, and your line of best fit doesn't have to start at 0, 0. So I started at between 20 and 30 because it fit my data more. What would you expect the cost to be for a 30-inch TV? Again, the expect word is really key. Okay, we're just trying to predict or guess based on our line of best fit, not actually from our data points. So if we look for a 30-inch TV, I kind of come up, it's going to be a little bit less than 500. So if I look at my answer choices, I'm going to pick 400. 700 would be too high, it would be up here, right? And then 1,400 is definitely too high. What is the cost for a TV that is 20 inches? This isn't asking us to predict or what we expect, so it's exactly from the data. So 20 inches, it's, you know, a little bit in between 0 and 500, so we're going to say it's $250. Again, we're going to predict for this next one, predict the cost for the TV that's 70 inches. So if we look at our data over here, 70 inches, if we come up to our line of best fit, is going to be about $3,500. Okay, next we have to identify whether the data set has positive, negative, no correlation, or constant just based on the scenario. So the first one, the number of hours a person has driven and the number of miles. Well, the more hours you drive, the more miles you drive. They're both going up. They're going to keep climbing, so that one's going to be a positive correlation. As you drive more, they're going to go up. The age of the car and the value of the car. Well, the older a car gets, the less it's worth. As soon as you drive it off the lot, it's worth less money. So that's actually going to be negative, right? As the age gets higher, the price is going to drop, so it's going to go down. A student's shoe size and their grade in math. Well, it doesn't matter what your shoe size is, it's not going to affect your grade in math, so that's going to have no correlation. They don't affect each other. The number of years a person went to school and their income, the more you go to school, the more money you're going to make, right? If you're becoming a doctor, a lawyer, or some of those things that require extra schooling, you're going to make more money than everyone else. So that is a positive correlation. And then the last one, the amount of food you ate and how hungry you are. Hopefully the more you eat, the less hungry you get, so that's going to be a negative correlation. And our final ones, just to kind of review those same things again, this one, our correlation is going to be none, right? These don't go up or down, they're just scattered all over. Our next one is going to be positive, it's going up from left to right. And our final one is negative, it goes down. I hope you found this video helpful. Please complete your homework and have it ready for class on Monday.